This video goes through some more quadratic equation examples. We have learned about some methods about approaching quadratic equations being equations with squares. So we've got a few options. We can graph the equation, we could factor once it's equal to 0, factor and solve each factor to 0. Now then there was the square root property, which led to the completing the square method, which then led to the quadratic formula. So sometimes the quadratic formula is the quickest. However, some of the other techniques can also be useful. Completing the square especially is useful when graphing quadratic functions. So don't just write it off as too complicated, because it will be very useful and you won't be able to use the quadratic formula. So it's good to have a knowledge of all of them, because some of them are more useful in certain cases. So let's just take a look at a bunch of different examples and see what we can do. In this first example, you'll notice that in order to get this into the format that's needed for the quadratic formula, which is ax squared plus bx plus c equals 0, and then x's are equal to whatever this formula tells them to be, in order to simplify that into that formula, there's quite a bit of work. So that's fine, but we don't have to do that work in this case because we've got brackets squared equals 10. So we can actually use the square root property directly. Because it's an equation, we can take the square root of both sides, which then leaves us with the absolute value of 2x plus 5 is equal to root 10. But remember, that means that 2x plus 5 is equal to either plus or minus root 10. Then we can just solve for x. So we have 2x is negative 5 plus or minus root 10. Divide it all by 2, or both parts by 2. And nothing can simplify. Remember, we're not looking to try to simplify this way. The only way you would be able to simplify is if you can factor a common factor out of the numerator, which we cannot in this case. The root 10 does not simplify. There's nothing else we can do, so we're done. Okay, this next one, we could remind ourselves about the completing the square property, because we've got the first two parts, and we don't have the third part in order for it to be a perfect square. So we need to figure out what to put here so that it goes back in there into a perfect square formula. And remember, that was half of the middle term squared, which in this case is 7 over 2 squared, which is 49 over 4. But if we add 49 over 4, we have to subtract 49 over 4, or add it to the other side. So eventually it'll go here. But this part will now become a perfect square, so that's x minus 7 halves, according to the perfect square formula. So now we can use the square root property, which then tells us that we can take the square root of both sides, leaving us with x minus 7 over 2 equaling the plus or minus root of whatever was here. But we got to figure that out first. So let's just do that on the side. What's 10 plus 49 fourths? Well, 10 was 40 fourths, and we're adding 49 fourths, so that's 89 fourths. Notice that that's taking the root on the numerator and the denominator, so that's actually equal to plus or minus root 89 over 2, because root 89 over root 4, and root 4 is 2. That's great, because that's a common denominator. So we can add the 7 over 2 to both sides, so we get 7 over 2 plus or minus root 89 over 2. Now root 89 does not simplify, so we can't do anything further with that. We could also write it as 7 plus or minus root 89 all over 2. And you could find your two possible answers by typing into your calculator 7 plus root 89 over 2, all over 2, which is 8.2, or 7 minus root 89 all over 2 would be negative 1.2. Now these are approximations, so if they ask you for those, then provide them. However, this is a more precise answer because anyone could decide to what degree they want to simplify it. Notice that in this case, because this equation could have been rewritten as x squared minus 7x minus 10 equals 0, it would be pretty easy also to use the quadratic formula. So you would input a equal 1, b equal negative 7, and c equal negative 10 into your formula. So try that out and see if you get the same answer. The formula actually does the exact same thing that this is doing because the formula is made based on the completing the square process, which is this process here. So let's take a look at some more examples. Let's play around more with the quadratic formula here. However, notice that you can always attempt factoring too. So see if something factors, because that's actually almost sometimes can be quicker depending on the factoring strategy. So here let's just check that out. Do we have a product of negative 2 that sums to 3? 1 times 2 is the only product, and there's no difference of 3 between 1 and 2. So this is actually non-factorable over the integers. And normally in the past we would just say non-factorable, but now we have this new artillery that can give us answers that are not so nice and integer-like. We can get answers that are non-integers. So let's try the quadratic formula here. We know that a is 2, our b is 3, and our c is negative 1. So if we plug it in, we have negative b plus or minus b squared minus 4ac over 2a. Let's run that through. That's negative 3 plus or minus 9 plus 8. So that's 17 in the root over 4. 17 does not simplify, so that is all we can do. There's no common factor that we can take out of the top, and that's it. So that means that because that root there does not simplify, that means that we weren't able to factor, and we indeed weren't. This next example has some fractions. Because we don't like fractions necessarily, but we have an equation, it's nice to consider multiplying everything by the common denominator. So that'll leave us with 5r squared plus 2r, and then we'll bring this over as minus 4 equals 0. So again, we could try to factor product of negative 20, sum of 2, 1 times 20, 2 times 10, and 4 times 5. None of them have a difference of 2. It's non-factorable. So we need to either complete the square or use the quadratic formula. So you could complete the square, but let's use the quadratic formula because that's why it's there. So we take our negative b plus minus r b squared minus 4ac over 2a. Running that through, you get negative 2 plus or minus 4 plus, and that's 20 times 4, that's 80 over 10. So that's negative 2 plus or minus root 84 over 10. Now this one can simplify a bit. The 84, let's look at how that's simplified. That's 2 times 42, which is 2 times 21, which is 3 times 7. So a factor of 2 comes out, a 21's left in. So we've got negative 2 plus minus 2 root 21 over 10. And be careful here. You don't want to just cancel here like that. Remember, you can only cancel if it's a factor. So let's factor out a 2. That'll be -1 plus or minus root 21 over, and 10 is 2 times 5. So really the 2's cancel because they are factors, and the rest of it is our answer. We could also have another example with fractions, another rational equation. So again, what's our LCM? And let's multiply through by it. Well, our LCM in this case is 3y, y plus 2. So if we multiply through by it, in the first term the y's will cancel and you'll be left with 3y plus 2. The second term the y plus 2 will cancel, you'll have 3y. Last term the 3 will cancel, you have y times y plus 2. Run that out. That's 3y plus 6 plus 3y equals y squared plus 2y. Get it all on one side. I'm going to keep it on the right because that's where y is positive. So this is actually a 6, so we'll subtract 6y from both sides, that leaving us with -4y, and we'll also subtract the 6. So there we have it. Now can that factor? 6 can be 1 times 6 or 2 times 3. Neither of those have a difference of 4, meaning it's non-factorable over the integers, so we could either complete the square or do the quadratic formula. So completing the square, just because I've been doing the quadratic formula a lot, let's just look at how that would work here. We'd want to add and subtract something so that this bit will be a perfect square. So let's check that out. What's half of the middle term? Squared. Half of 4 squared. So half of 4 is 2, and then square it. You'll actually be adding 4, but because we've added 4, we need to subtract 4 in order to compensate. So this trick is going to be really useful in the future, so that's why I'm looking it over here. Sure, you could use the quadratic formula, but let's practice this. So this bit here becomes y minus 2 squared, and this here is -4 minus 6 is -10. So that means that we have y minus 2 squared equals, add 10 to both sides, equals 10. The reason why I chose to do it here is because I saw the 4 and I said, well, that's a nice easy number to take half of. Let's try it out. So when we use the square root property, we're going to end up with y minus 2 is equal to plus or minus root 10. And now when we add the 2, we get 2 plus or minus root 10. Awesome. Now let's just take a step and say, what if we use the quadratic formula? Well, then we'd have x equals our -b plus minus b squared minus 4ac over 2a. So that's going to be 4 plus or minus root, and that's 16, plus 24, which is 40, over 2. So 40 is 2 times 20, 2 times 10, 2 times 5. So factor of 2 comes out, so you have 4 plus or minus 2 root 10 over 2. But in order to simplify, a lot of people would just cancel out these 2's or something. But remember, you can't cancel anything until they're factors. So factor first. Take out a common factor of 2, you get 2 plus or minus root 10, and that's all over 2. The factor of the times 2 can cancel with the bottom 2. And why are we crossing them out? Because we're dividing both sides by 2. So remember, you can't just cancel things out here. Remember to factor first. Here's another example. So this one here, you've got a square root. So you can actually square both sides right away, and then you get 2x squared. So 2x times 2x, which is 4x squared, equals 11x plus 3. And so when we put that into our format, we can now use the quadratic formula. Negative b plus minus b squared minus 4ac over 2a. So we get 11 plus or minus 121 plus 4 times 4 times 3, which is 169 over 8. Oh, look at that. 169 is actually a perfect square. That means that our initial polynomial here could have been factored. So this is actually 11 plus or minus 13 over 8. That gives us two answers, either 11 plus 13 over 8, which is 3, or 11 minus 13 over 8, which is negative 1/4.